As promised, time to introduce the empirical rule. The empirical rule simply outlines where most values fall in a normal distribution. So around 68% of the values live within one standard deviation from the mean. Around 95% of them live within two standard deviations. And around 99.7% of them live within three standard deviations from the mean. So why is this relevant to us? Well, these are handy numbers to have in our mind to put some context around the z-scores. If we look at our project example, if a student has a z-score of minus 1.7, well then that's not unexpected since 95% of all students will fall within two z-scores from the mean. But if a student has a z-score beyond 2 or negative 2 though, then he's either performing really well compared to everyone else or really poorly. Aside from that, it's also a good way to check if your data is distributed normally, aside from just, eyeballing it using a histogram like we have before. And let me show you exactly what I mean by that in Excel. Here in the Excel statistics workbook, let's go to the empirical rule link. And let's say that we want to use the empirical rule to find out the grade intervals in which most of our students will fall. We have our normal distribution of MBA grades, so let's see which grades are within 1, 2, and 3 standard deviations away from the mean. So let's calculate these values. The lower bound or the lower grade here is going to be equal to our mean minus 1 times the standard deviation. And let me fix these two values with F4. Press enter. And now let's calculate the upper bound, which is going to be equal to, again, the mean, F4, and this time plus 1 times our standard deviation. F4, press enter. And let's apply these to the right to get our intervals for 2 and 3 standard deviations as well. So what do these numbers represent? Well, according to the empirical rule, if our population of MBA grades is normally distributed, then 68% of all students will get final grades between 74 and 86. 95% of them will get grades between 67 and 92, and 99.7% of them will get grades between 61 and 98. So what we can do now is check to see if these students from our sample are distributed in the same manner. So let's calculate that. We want to count, so I'm going to use countifs. The number of students here, or the number of grades rather, and let me fix that, that are greater than or equal to 74. That's our first criteria, and the second is that these same grades, fix those as well, also need to be less than or equal to 86.3. Let's close our function. So this is going to count the number of grades that fall within these bounds or within one standard deviation from the mean, but we actually want to get the percentage of grades. So we need to divide that by the total amount of grades. F4 one more time. Let's press enter. And let's apply this to the right. And would you look at that? These are almost exactly the same. So it turns out that we weren't too far off to assume that these grades follow a normal distribution after all. So now that we're safe to assume that, time for the good stuff.